Welcome to 5G Technology World. I'm site editor Martin Rowe. Fujitsu Network Communications, a provider of wireless infrastructure equipment, has contributed O-RAN-compliant 5G radios to the Telecom Infra project. The radios, a dual-band radio that operates at bands 70 and 76, and a tri-band that operates at bands 71, 29, and 26, both use the 7.2 functional split between the radio and the Open RAN DU, or distributed unit. TIP now lists these radios in its marketplace page. To find out more about these radios, how they work, and how they work as part of the Telecom Infra project and an Open RAN ecosystem, we spoke with Fedi Adeyemi, head of the wireless business unit at Fujitsu Network Communications. Fedi, welcome to 5G Technology World. Tell us, how do Fujitsu's radios connect to the radio access networks?
These radios, there are two of them, a multi-band and a triple band radio. But what is unique about these radios is the interface that it's using to connect to other parts of the network. Previously, in generations before, we've been dealing with something called CPRI, Common Protocols for Radio Interface, that was supposed to be common to radios, but was not common. The vendors, they figure out a way to tweak the interface so that two radios would not be able to connect to a BBU. What Fujitsu has been doing over the last, probably getting close to about 5 years now, is to work with a consortium of suppliers, carriers, to build radios based on this open interface. And the open interface on the radio side to the BBU is called 7.2x, whereby a single radio can connect to multiple BBUs, or multiple BBUs can connect to a single radio. So this has really opened up the business of for carriers. There are a number of benefits this positions, but we can talk about them later. But that's the simple definition. It's the interface for that radio is open. It's open standard. In some cases, it's open software, so that we can mix and match and lower cost. It leads to a better supply chain for carriers, and a host of benefits that we can discuss.
We usually think of multiple RUs, radio units, as talking to a single distributed unit, DU. Is that always the case? Or can a radio unit also talk to multiple DUs?
The commonality between the DU, so you are correct. In 5G, a BBU is basically broken into two, or disaggregated into the centralized unit, CU, and the distributed unit, the DU. Now, depending on the architecture that a carrier is deploying, it is possible for a single DU to talk to multiple radios from different providers under this open interface, because the interface between the DU and the radio RU is now understood by both sides, okay? It is also possible for a single radio to talk to multiple DUs, depending on how it's built and what it supports. So the Fujitsu radio, because it's a dual band radio or triple band radio, can actually talk to multiple DUs, okay? Or a single DU can talk to multiple radios. It depends on your architecture that you're running. And then again, the architecture also dictates where that DU is placed. With O-RAN and 5G and the disaggregation, the architecture is amenable to, you can co-locate the radio and the DU at the base of the tower. You can aggregate the DU in a central location, the one that we call a local data center. So a data center that just has the DU and then fan out to the radio and fan out to the CU. Or you can co-locate the DU and the CU in a central location as well. So the ability to disaggregate actually gives you more options in terms of how this is deployed. And there are various benefits that you get from this. For example, in the case where the DUs are aggregated at a local data center, you can actually fan out from that local data center to multiple radio locations, okay? In which case, you've saved on your real estate that you need at the base of a tower. You can literally just hang your radios on top of an antenna, on top of a tower, and the real estate to have something at the base of the tower is gone. So in addition to the real estate, you're talking about power saving and a host of other things. So the ability to disaggregate, and then the open interface, open APIs, that like you call it, has really now led to a host of benefits, as well as new entrants are now coming into the play to be part of RAN deployment. Because, and the reason is, along with the disaggregation, you now have the ability with the power of the processors that we have and servers to run the DU and the CU either in the cloud or on general purpose servers. That again has really opened up the RAN space, where now companies that in the past they've been noted for providing servers are now coming into the RAN space. Software companies are now writing software that can run on servers. So a host of innovation, a host of new entrants, a host of business cases, a host of use cases are now popping up left and right.
The Fujitsu radios that are now used as part of the telecom infra project use the functional 7.2 split, by which the low-fi functions reside in the radio, hi-fi functions and all of the digital functions reside in the DU. How does that functional split affect the distance between the radio unit at the tower and the DU?
So traditionally with CPRI, there's a limitation of about 20 kilometers from where you have your base station to where the radio can be, because of latency issues. With the functional split, some functionality now have been moved from the base station into the radio. So now we talk about 7.2 split. But what the O-RAN interface has actually also done is to give you various parameters, transport parameters, that you can actually tweak. And as you design the network between the DU and the RU, can actually extend beyond that limitation that you have in CPRI. So for those who do not know, I'm actually saying you have better performance in terms of how much distance you can have from where the DU is to where the radio is. I've designed a network now based on this O-RAN that actually doubles what you can do with CPRI. So to me, it gives more flexibility than actually limitations.
Fujitsu claims that these two radios support world-class power consumption. Can you explain how they achieve that?
The radios that we're offering up for this in the press release, they're actually very condensed but very powerful radios. There are multiple bands. One has 3 bands, the other one has 2 bands, and each of them, they actually support higher number of carriers. So when these things are fully loaded, you're talking about almost like 3 to 4 radios in one. Okay, what we are calling world-class power saving is traditionally, if you have a one carrier or 1 band and a single band radio, the efficiency that you get is on the order of probably maybe 30% between your the total power consumption versus the power that the radio is pumping out from RF point of view. Because we have multiple bands and multiple carriers, and the experience that Fujitsu has developing radios in terms of size, form factor, how we dissipate heat from the radio, we are actually able to get close to about 25% in terms of power consumption. So you use essentially the power consumption of the radio is very small compared to the output power that is coming out of the RF port. So it's a combination of our technology and experience that has led us to achieve such a feat. Fujitsu is actually noted for our technology around power amplifier, that it's our own innovation that is able to give us linearity over a longer range compared to what you just buy off of the shelf in the industry. So the combination of that power amplifier and the algorithm that runs behind it to be able to give you that linearity, as well as how heat is dissipated off of the radio, effectively led us to being able to have an efficient radio in terms of power consumption.
Do these radios, the dual band and the tri-band, support beam steering?
This particular set of radios, they do not support beam steering, but we are building other radios that are massive MIMO capable, that are able to steer beams, that are able to innovatively target beams also. So there's beam steering, there's beam targeting, and there's beam creation. So the set of radios that we're talking about, they have static beams, but we are building other radios that are MIMO capable and can generate beams on their own. For those, it depends on the use case that we're developing them for. Some of them, they are as powerful as 64 by 64, about 196 antenna elements. Some are 32 by 32, and they have less number of antenna elements, maybe 128. So with those antenna points, you can, on the fly, in some cases, coordinating with the DU, or in other cases, all on its own, the radio can generate beams as needed.
What do you mean by static beams? Is it omnidirectional, or is it constrained to some angle of usage? And what would be the application for that?
What I mean by static is also to say that the beams are pre-configured. Now, although the beams are pre-configured in various directions, they can actually, you can use different antenna to push out the power from those radios. So you can use omni antenna if you choose. You can use sectorized antenna. It depends on the choice of the deployment. So what I mean by static is actually saying the beams that will come off of those radios, they are pre-configured. And you can direct the power of those pre-configured beams into a sector or into an omni antenna, depending on your use case. Beams that are generated from a massive MIMO point of view can move with the users or can be targeted at a particular location. These ones are pre-configured. They don't move with the users.
Does it support more than one beam, or is it is there a single beam for each radio?
These radios, they support 4 beams.
What kind of transmission distance can these radios achieve given factors such as frequency, topology, or antenna height?
Range is a very interesting discussion to have, but there are multiple factors that leads you to how much range you can have. The height of your antenna,
Of course.
where your radio is placed, the spectrum at which your radio is operating. If it's the lower the frequency, the longer your reach.
Of course, yes.
Like you mentioned, it's also a function of your topology, whether you have trees or you have or you're in the desert. That will also affect the propagation from the radio. But typically, if it's a sub-6 radio, you can get up to between 10 and 15 miles from an antenna, depending on how high it is and the topology that you're operating in. Now, the higher you go in frequency, let's say in the mid-band, or you're now talking, yes, mid-band, 2.5, 3.5, the range begins to reduce because the propagation is now reduced physics. You will now be dealing with on the upwards of 3 to 5 miles. And then the higher you go into the higher frequencies, in the millimeter wave, your propagation actually completely reduces to only thousands of miles, or only thousands of feet. So it depends on a number of factors.
Can you tell us a little bit about the telecom infra project and how these radios are being used as part of that project?
The telecom infra project is a consortium of providers who have joined with TIP to offer radios in what we are calling an open market. These radios, the common factor between them is that they support this open interface or open APIs. And then there are a number of certification that TIP puts in place that allows you to join and be a part of that marketplace. So essentially, the radios, and I'm on the complementary side, the DDUs, the BBU, or the DUs or the BBUs, we also have the same kind of certification where based on those certification, whether it's whether it's independently tested, you get a badge from TIP. That badge allows you to be a part of the marketplace. Then any operator can now go to that marketplace and really look at what is available to me that I can deploy, that has been, quote unquote, certified by TIP as ORAN compliant. So Fujitsu is we're very happy to be a part of this because our whole strategy going forward is to build ORAN compliant solutions. And so it's natural for us to be part of this consortium. A larger market will have access to the technology that we're providing.
Adeyemi, thank you for meeting with us today. And for 5G Technology World, I'm site editor Martin Rowe. Thank you for watching.